Another question of Hessian metrics here. So we have our multivariable function f of x, y, z equals to exponential xy plus cosine of yz minus x z squared. Okay? So that's the function that we're dealing with over here. So don't worry about what we have on the side here. Just leave it, as that for now because we're coming back to it. So to get the Hessian metrics, that means we need our second partial derivative. Okay? But before we get to the second partial derivative, we need the first partial derivative. So let's go with the first partial derivative. What does that mean? To get to the first partial derivative, that means we're going to have to find it, for x, for y, and for z. So let's go for x. So that means whenever we see x, that's what we're going into. So that means the first term and the third term. So what would that give us? With respect to y, that means to x, so that means y coming out. So it's going to be y exponential xy. And then with respect to x, that will give us what? Negative z squared. Okay? Then we have to do it with respect to y. First partial derivative with respect to y. So that means the first term and the second term. So for the first term, what's happening there? So that means because y is our target there, so x is going to be treated as a constant, so x is going to come out. So it's going to be x exponential xy, okay? And then for the second one here, with respect to y, so that means, first of all, the derivative of cosine is negative sine, and then we have another function in here, which is yz, and with respect to y, the z is going to come out, okay? So we have a composition of two functions, cosine function, and then the yz, okay? So that would give us negative then z sine yz. All right? And then we have to do it also with respect to z. Let's not forget about that. So it's x, y, and z. So with z, that's the second term and the third term. Okay? So that means this one is going to be also a 0 because we're going to consider that as a constant. The derivative of a constant is 0. That's the reason why I wasn't talking about the other ones. Okay? So with respect to z, so once we come here, so again we have a composition of two functions there. So cosine function and then yz. So with respect to z, that means y is going to come out. And then what is the derivative of cosine is sine, negative sine, so it's negative sine yz. All right? So with respect to z, the y is the constant, so the constant comes out. And then the derivative of sine is negative sine yz. Okay? And then, last but not least, on this one, so with respect to z, what's going to happen? That gives us negative 2xz. Okay? So that one is dealt with for the first partial derivative. Now we got to go for the second partial derivative. So we're going to have 3 lines, and then we are actually looking for a 3 by 3 matrix. Okay? 3 by 3 matrix with our 3 variables. So what's going to happen? So we go, and then we're going to do it with respect to x the second time. That's why we're going to have square here. So we're going to have the x line, the y line, and then the z line. Okay? For all 3 variables. X line, y line, and then the z line. So for the x line, we go in order. We get x, y, and z. And then we're going to continue to do the same thing for the others as well. So let's go at that. So that means we're targeting the first partial derivative with respect to x. That's why we're here. Okay? Now once we get in there also, we have to target x. No x here. That means we're going to take this one as a constant. Derivative of a constant is going to give us 0. So we get back here. So with respect to x, so that means y is going to come out. But because we have another y already, we're going to multiply. It's going to be y squared exponential xy. Okay? And we cannot go further because this one is already 0. So then, let's go now x with respect to y. So like we said, we're going to do x, y, and then z. Okay? So now that means we're getting y. We have y here times exponential xy. So we have 2 functions. Because we have 2 functions, that's the reason why we had this. So that's the product of 2 functions, and then the derivative of the product of 2 functions is f prime times g plus g prime times f. And that's what we're going to do. What's the first function here? That's y. So the derivative of y is going to give us 1 because it's with respect to y. So that'll be 1 times exponential xy. So once we get that, so that's a plus. Now g prime is what? So g prime, so with respect to y, so that will give us what? It's going to be x times y exponential xy. Okay? And then for this one here, last but not least, with respect to z, so that means we're going in here and look for z. So that's the second term. The first one doesn't have z, so that's going to be considered as a constant, which becomes a 0 as a derivative. So this one, the derivative of that will give us negative 2z. All right, so we are done with the first one. That's the x line. So we go now, y line, and then with the y line, again, we begin with x, y, and then z. So let's go at it. So that means we're going to have to cater to this one here. So this one with y with respect to x. So what do we see for the first term here? For the second term, we don't have anything, is any x in there. So that means this is going to be considered as a constant. So derivative of that is going to be 0. But this one here, we have, again, two x's, functions. So we have function x and then function exponential xy. So again, we're going to apply the formula here. So x, derivative of that is 1 times exponential xy, okay, plus g prime. So g prime with respect to x, so that gives us y. So the y is going to come down with the x, that will give us xy exponential xy, okay? And then here we go. Now with respect to y, so that would be y twice. Okay, with respect to y, so that would be y twice. Remember, x, y, and z. So let's go at that. So we're looking for where we have y. So for the first one here, we have y here. So if we find the derivative of this one with respect to y, so x is going to be the one to come out, and then that will give us another x, so that will be x squared because both of them will multiply, and then exponential xy. Now when we get here, we also have y there, so y here, so the derivative of that, the z is going to come out because it becomes a constant, that will multiply this z here, that becomes a z squared, but don't forget we have a sine function here, and the derivative of a sine function is positive cosine. So it's going to give us minus, because the plus sign will not change the negative, minus z squared cosine yz. And then to finish with, we have y with respect to z. So what's going to happen here? So the first one does not have z, so it's going to be considered as a constant, so that gives us a 0. Okay? And then now we get to this part, and then with z, we have also z here, and then another z in here. So we have two functions again. So we have to apply the product of two functions, the derivative of that. So that would give us what? So that would give us the derivative of z, which is 1 times the g, which is negative sine yz. So it's going to give us negative sine yz. And then we have to do g prime, so that means the derivative of this one here with respect to z, so the y is going to come out, and then derivative of sine is cosine, so it's going to be negative yz cosine yz. Okay? And then we get back here, and then we have it with respect to z, so it's z and then x first again. So that means we're looking here. So for x, where do we have x? No x here, but we have x here. So that will give us what? With respect to x is going to give us negative 2z. All right? And then that's it for that. And then we go now, z and then y. So whatever we have y. So whatever we have y, we have two y's over here also again. So the product of two functions, so we're getting to this again here. So what did that give us? So the derivative of this one is 1 times this, which is negative sine yz. Okay, and then g prime times f. So g prime with respect to y, the z is going to come out, and derivative of sine is cosine, so it's going to give us negative. Then that'll give you yz cosine yz. All right? And then last but not least, we have to do it with respect to z again. So that will give us z squared. So whenever we have z, right? So we have z here, we have z there. Okay? So that means when we do it with z here, constant is y is going to come out, multiply the y, that gives us y squared. And then the derivative of sine is cosine, which is positive, but because we already have a negative there, so that will give us what? That will give us y squared. Okay, cosine yz. And then the derivative of this one with respect to z, so that will give us negative 2x. All right, so we're basically done. And then we get our 3 by 3 matrix. Okay, 3 by 3 matrix. Okay.